Yo, 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 yo. Everybody, this is the 3.2 video, rate of change and slope. So let's just get right into it. So first key term is rate of change. So it's a ratio. Rate of change, we write it as a ratio of the amount of change in the dependent variable, the output, to the amount of change of the independent variable or the input. Let me also write a way for you guys to write down rate of change. Rate of change is change in y over change in x. So you can write down this that I have here for slope. You can also include this for rate of change. Okay, now rate of change and slope are very similar. They're almost the exact same thing. Well, slope is a version of rate of change. So, but really rate of change, this whole definition is just a way of saying find out your change in y and divide it by the change in x. So the change in y divided by the change in x. So I want you to write this down twice then, I guess is what I'm saying. I want to see change in y over change in x over here for your definition of rate of change. And then I want to see change in y over change in x in your definition of slope. Change in y and change in x for slope is also the same thing as rise over run, which is also the same thing as y minus y over x minus x. All three of these are the exact same thing. This means this means this. So these can even be equal signs if we want them to be. These are three things to talk about slope. Three ways different ways to talk about the slope. And we'll get into that right now. But you're going to see here or see me talk about slope as change in y over change in x. You might hear me say rise over run. This is when we talk about it on a graph. Y minus y, x minus x. This is when we're just looking at points. Okay, when I'm looking at 2 points, we'll use this version. And change in y over change in x is really when we're looking at a table. We're going to figure out, okay, well, what's the change in y and what's the change in x? Okay, so that's why we talk about it in three different ways. It kind of depends on what we're looking at. But let's get into it. So Eve keeps record of the number of lawns she has mowed and the money she has earned. Tell whether the rates of change are constant or variable. So here's what we need to do. We need to find out the rate of change. The way we find the rate of change is we find the change in my x values and my change in my y values. So rate of change is the change in y divided by the change in x. Change in y over change in x. So what I'm trying to figure out is how much is my y changing from here to here, from here to here, from here to here. So if I look from 15 to 45, my y goes up 30. From 45 to 90, it goes up 45. From 90 to 120, it goes up 30. What I'm doing is I'm comparing that with my change in x. So the top is my x values. The change in x is up 2. From here to here, we go up 3. And from here to here, we go up 2. These are my fractions that I use. So we're not checking proportionality anymore. We're checking to see is my rate of change, what's the rate of change, is it constant or variable? If it's constant, that means that these are going to be the same values if I set it up as change in y over change in x. So here's what I mean by that. The change in y here was 30. The change in x was 2. So that's 30 over 2. Well, 30 divided by 2 is 15. That means the rate of change was $15 per lawn. Well, I also want to do that with my second set here. So that'd be the change in y was 45. The change in x was 3. 45 divided by 3 is 15. My change in y was 30. My change in x was 2. 30 divided by 2 is 15. I got the same answer each time. That means the rate of change was 15, and it is constant. It's constant because that means this person, Eve, charged $15 per lawn every time, no matter what. They didn't decide to change their price on day 3. So the rate of change was $15 per lawn. And it's also a proportional relationship. And we'll get into how this compares to proportionality later. So it is a constant rate of change of 15 because it goes up 30 over 2. I'm sorry, up 30, up 2, which 30 divided by 2 is 15. 45 divided by 3 is 15. 30 divided by 2 is 15. Okay. We also use rate of change, and we call it slope. Okay, so you might be asked to find m, or the slope of a line. Slope is also rate of change. So again, it's the change in the y values and the change in the x values. Okay, so it's change in y over change in x. So change in y over change in x. Another way we talk about change in y is the y values on a graph are these values going up and down. The x values on a graph are these values going left and right. So that's where you see the term rise over run. Because that's why we call it slope. We call it slope when we're actually looking at a line, even though rate of change and slope are the same thing. So we call it slope when I'm looking at a graph or a line on a graph, and I'm looking for the change in y and the change in x from two perfect points. Okay, so I can pick any two of these points. And what I'm doing is I'm figuring out how much does it go up from here to here and how much does it go left and right from here to here. That's what is the rise and then what is the run. So if I look at the rise is going up and down. That's the change in the y values. Well, to go from 0, this is 15 right here. So if I want to go from 0 to 15, the rise is up 15. Because 0 to 15 is just going up 15. The run is going to be how much I go from here over to the side. So I go up 15 to go from here to here. The run is how much do I go over from here to here. Because basically I'm trying to figure out how much I go up and over to get from this point to this point. I went up 15 because that goes from 0 to 15. And then I go over, well, this is counting by ones. So I go over 1. So the rise is 15 and the run is 1. So the slope of this line is also 15, which is very similar to this. This is actually would have been the exact same graph if I asked you to graph this one right here. So my rise goes from 0 to 15. So I go up 15. That's a change in the y. The change in the x was from over 1. And if we look, and that pattern maintains the same for each of these points. If I look for these 2 points, my y goes from 15 to 30, right? So it goes from 15 to 30. Well, 15 to 30, that's a change in y of 15 because I go up 15 from 15 to 30. And I still only go over 1. From 30 to 45, it's going up 15. Ooh, I missed that one by a lot. Yikes. I'm going up 15, and then I'm going over 1. Up 15, over 1. It maintains that pattern as rise over run. So the slope is just 15. So, and we use m to represent slope. So m equals 15 because m is the variable that we use for our slope. And m is a variable that we use in formulas.
James Keyser.
Okay, but sorry for that interruption. Now, so graph, change in y over change in x. My change in y is how much am I changing going up and down from one perfect point to the next perfect point. Okay, all right. So here we go. 2 problems very similar. We're going to look at these ones, and we are going to tell if the rate of change is constant or variable, and then we're going to find the rate of change. So this is a table where x's are always on the left, y's are always on the right. So I want to figure out my change in y over my change in x. I'm just abbreviating the word change to ch. You should probably write out all of ch, change, okay? So my change in y, well, let's see. From here to here, I go up 18. From here to here, I go up 13. From here to here, I go down 5. Okay, so that's fine. Even though the y's are changing differently, we want to compare it to how we're changing over here. So my change goes up 0.5. So this is going to be 18 over 0.5. Then I'm going to go up 1. So that's going to be 13 over 1. Because from 0.5 to 1.5, it's changing by 1. 18 to 31 is changing by 13. So that's why I went 13 over 1. And this is down 5. And then this change was 0.5, up 0.5, over 0.5. So the changes are kind of funky on this one. They're weird. So we're counting up by a half, up by 1, up by a half, up by 18, up by 13, and then down 5. So this is sorry again. So this one, basically, if we look at the rates of change, they're different. Because if I do 18 divided by 0.5, I plug that into a calculator, I'm going to get 36 over 1. Well, 36 over 1 is automatically not the same as 13 over 1. And this one's a negative. This is going to give me negative 10 over 1. So all of these rates are different. What that means is that this is a variable rate of change. It means the rate of change is different. It's changing. Okay? So those are my 3 rates of change, and then therefore it's not constant, it is variable. Now the reason why it's variable is because when a football is kicked, the football is maybe picking up speed as it's going, but when it kicks, it goes up like this and then it starts coming back down. At this point, it's actually not moving as fast. This is the point where it might be slowing down, and now it's changing its direction, and it might be its height's going to change as well. So this is why it's going to be a variable rate of change. Okay? So that's that. Look at this one. See if you guys can find the rate of change of this graph on your own. See if you can count the rise and the run from this point to this point, or you can go from the origin. You can go from this point to this point. Count your rise, count your run, and see if you can find the slope of this line. Okay, so hopefully you paused and you already answered this, because I want to see if you did it on your own. So from here to here, I want to know, well, what is the rate of change of this line? What is the rate of change of this particular tank that's leaking? Okay, so it's leaking, what is it, leaking water? Yeah, it's leaking water. So I want to see how many gallons per minute is this leaking. Well, my rise, or my rate of change, let's just go from here to here. It goes up 1, 2, 3. I'm going from 3 to 6, which means it's going up 3. So the rise is 3. The run is 1, 2, 3, 4. And then it goes over in 4 minutes, because it goes from 4 to 8 minutes. I went from 4 to 8 minutes, and then I went from 3 to 6 gallons. So my rise was 3, my run was 4. Rise over run is 3/4. So the slope is 3/4. Now, again, let's go back. I want to erase this so we can look at it another way. Oops. Because this is big stuff. This is important stuff, guys. So from here to here, if we count, it goes up 1, 2, 3 over 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4. And because it's rise over run, the rise is how much we go up and down, so we call it rise. So I went up 3 over 4, up 3 over 4. And it's actually going to maintain that pattern. Okay, so that's up 3 gallons every 4 minutes, which is really 3/4 of a gallon per 1 minute. And that gives me my slope and my rate of change. Okay, I'm done. Things to remember. Slope formula, that was y minus y over x minus x. Rate of change, if the relationship is constant, it creates a straight line. Okay, so when we talk about slope and a constant rate of change, we're always talking about a straight line. As soon as it's variable, that's when we have maybe a curve of some kind. Okay, or it's definitely, or it might be curved like this. It just depends on the situation. But if it's a constant rate of change, that means we can find our slope, and then the slope is making a straight line. Okay, go ahead and try the rate of change for this one, constant or variable, and then find the slope of this one. If you guys have any questions, please don't hesitate to ask. Gradius out.